Thank you for coming here to the 5G and DoD breakout today. I'm Dwayne Florenzi with the Defense Innovation Unit, based in Mountainside, California. And today we're going to do I'm going to have our panelists do a little self-introduction, and then we're going to do 3 different presentations. I'm going to share about the mission for DIU, the vision for 5G, and then Ian's going to share Turbine 1, and John's going to share about CAPE, and then we'll open it up for questions and answers, and we'll pull in our DoD Indo-Pacific people more to try to get some more impact from them as well. So let me go ahead, and Ian, if you can do a little introduction for yourself.
Sure. Good morning. My name is Ian Kalin. I'm the CEO, co-founder of Turbine 1. It's an honor to be here. I served in the Navy for a little bit as a SWO, supporting maritime interdiction operations, later as a nuclear engineer, SWO nuke. And at Turbine 1, we deliver intelligence orchestration.
It should be on.
Oh, it's on. All right, great. Hey, I'm John Doyle. I'm founder and CEO of CAPE, Privacy First Mobile Network. My background is in the Army Special Forces. I was a commo guy at 5th Group, 2003 to 2008. Left the Army, went to Palantir, spent about a decade at Palantir, most of that time running the U.S. intelligence community business, and left to start CAPE 2.5 years ago. Thanks.
Yeah, hello, good morning. Good to see so many familiar faces. I'm Kurt Andrews. I'm the Joint Base Pearl Harbor 5G Initiative Principal Investigator. Before that, I worked with some people in the room on a program called Lightsaber involving LTE. This goes back to 2017, but good to be here and looking forward to your questions.
Hey, good morning. Chris Murphy, work for Defense Innovation Unit. Backgrounds both in the Navy and working at various UARCs across the technical space, from AI to systems engineering to many of our afloat weapon systems. More recently here on Oahu as the science advisor at PACFLT, and now at DIU I'm the technical director on the AI/ML portfolio and the lead embed at INDOPACOM, where most of my time has been spent thinking about fielding autonomous systems and how we're going to see to them at scale.
Great, thank you all. So I joined DIU about 6 months ago, and they tend to try to bring in people who have industry, they call it dual fluency, industry background as well as government background. So I've worked for Cisco, GE Digital, and Lucent Technologies, which is now Nokia Bell Labs, in mobile communications. And then in the DoD, I was with the Air Force, active duty as an attaché in Hong Kong, and also international relations in Japan, as well as acquisitions. So a number of different backgrounds that I think is very relevant. And so I've been thoroughly enjoying DIU, and you'll hear more about that as I share a little bit more about the mission of DIU. So DIU is accelerating the adoption of commercial solutions. So especially trying to tap into what's out there in the marketplace and bring it into the DoD as quickly as possible. And really an emphasis of making sure that these things are operational and really going to support our warfighters. I realize I need the clicker myself here. Where do we go here? What's wrong? Okay. Okay, there we go. Thank you. In 2015, the Secretary of Defense established DIU when they recognized that up to that point, so much of DoD was actually driving R&D for the world, and it was a major force. But with the .com, and we saw so many of the Silicon Valley companies, their market value came up. They were investing in research and development, and we saw a major shift here in the U.S. where so much of the R&D was going into the commercial side. And so you can see this chart here where commercial R&D is really taking off. And so DoD needs to tap into that, and that's really essential, and that's why I believe many of you are here, and we need you very much so. When DIU, Defense Innovation Unit, was first established in Silicon Valley, it was to try to start building relationships with some of the innovative companies in the United States. And so that's what this first part was, DIU 1.0. The next was to not just establish the relationships, but try to build a mechanism where we could bring technology in quickly to DoD. And initially, it was trying to figure out what companies are out there and bring the technology to DoD. But it was very hard to make the match to what was really operational. And so there was a realization that, no, we needed to first go and find what our end users need in the Department of Defense, and then put out a solicitation to industry to find out what's available there, and then bring that in. And so that's really been the method of DIU, which has been very effective. And then we get to, about a year ago, DIU is elevated to report directly to the Secretary of Defense and receive a significant budget as well. And we see a big emphasis that to try to tap into this method of bringing technology from commercial in quickly and to scale it and to really focus in on more strategic projects, things that are going to really move the needle. Where we see here is on the right-hand side, the top there, are the 7 different portfolios of DIU, the technology areas that we're focusing in on. That includes AI, ML, autonomy. I'm on the cyber and telecom team. Then we have emerging technology, which is a newly graded one, which has a big emphasis on quantum, energy, human systems, and space. And you can see at the bottom here, DIU represents all parts of the services. We have people from each of the services actually active duty embedded within DIU. And then on the left side here, all the different aspects, the couple that I want to highlight is, over the last year, DIU has been embedding people within the combatant commands. So a year ago, 11 people from DIU were embedded within the Indo-Pacific region. And we have Chris Murphy here, who is our representative here from DIU in the Indo-Pacific region. And then the other is global partnerships. We see over this last year, DIU actually putting people within countries so that we're trying to work together more closely with our alliance and partners. This is kind of the spectrum of where acquisition takes place. We're familiar on the far end, which is the FAR, Federal Acquisition Regulation, which is the normal process for larger DoD-type projects. And then the far left would be ordering off a price list from the GSA, the General Services Agency. DIU's sweet spot is in between there, where there's a product that's either close to commercial or it's just needs some minor tweaking to make it adaptable for DoD, and trying to pull that in through this solicitation process. And the beauty of it is then once a project has gone through solicitation and meets the success criteria, then it can be purchased through the other transactional authority, and then it can continually be purchased by DoD without having to go through a competitive bid again. Here we go. Which way? Let's see, what's next? Okay, we're still not getting there. The one thing I'll share is the next one I think is coming up in an example from the cyber and telecom team that we worked on. And that was the California, here, this is just the process that I was talking about, where we put out a solicitation and prototype. It's a quick process. At the end, I'll give you an email address or the website that you want to sign up for if you're interested. It's a 2-week, usually just advertised. The opportunities are only advertised for about 2 weeks. And it's a pretty simple process for responding. It's made purposely for smaller companies that can turn around pretty quickly without being burdensome. Then we do a prototype for 1 to 2 years, and then, as I said, after it meets the success criteria, we bring it online. This is the example I want to give. I'll ask. We'll have a lot of time for. Well, we'll have time at the end for questions. This is actually 2 years old. This is where the California National Guard was looking for a remote way that they could have mobile communications. And what was set up was a backpack with that Phoenix group, which is now part of Nokia. And they could do it either a backpack or a small vehicle. And then connecting to Somewhere Labs, which is a puck that has access to LTE, Iridium, and Silvus radio, I believe. And the mesh radio. Here we have Johnson Wu, who's an expert on that one, right here in the audience, so you can talk to him if you have questions about this. But then this grew to become interested by UCOM, and now we have the Marines involved in it, and so it's growing. And so this is just representative of a number of the different projects the DIU is involved in. There's people here in the audience that I know are involved in other projects that DIU and the Department of Defense is involved in that we're working on. And then we have 2 companies here that are more recent participants in what DIU is doing. So again, this is an area we can delve into questions with later, and what areas where I think we want to go further in the future. I'm going to shift a little bit here and talk about 5G, because 5G I think is an excellent example of where there's so many benefits from the commercial market that DoD can tap into. And DIU received funding on 5G over this past year and was involved in a number of the different projects. But the DoD has been working on 5G for the last 5 years, initiated by the Office of Undersecretary of Defense for Research and Engineering. Now it's called FutureG. And then the DoD CIO, the cross-functional team, has now taken responsibility for the active engagement with the services on 5G. And so now you see the 3 of our organizations working closely together to try to promote where 5G is and where 5G in the future is going. And so this is very relevant, I think, to DIU. And again, I think it's relevant as an example of where commercial has so many benefits that we need to tap into. So the vision is each generation of mobile communications has basically lasted a decade. And so we're now into only the 4th year, say, of where 5G is. And so we still have a ways to go of 5G maturing. And so 5G, the first part, was the top part of this triangle, which is the enhanced mobile broadband, which is an extension of 4G. But it's the other 2 parts of the triangle that are really transformational, capabilities that we didn't have before. And that is the low latency, meaning almost no delay, and then the connection to everything, the Internet of Things. And when you take these 3 things and combine it with mobility, and then the emergence of artificial intelligence, where you are able to have ubiquitous connectivity and the ability to make decisions almost immediately, that's what is really transformational. And that's where we're only entering into that now. And so 5G, 6G is really going to be transformational, and we're just getting into that part now. As I mentioned, each generation has had a decade where, a country or a region has been in the lead. You could say 2G was GSM in Europe. 3G, some might say Japan had a lead with iMode. And then 4G was clearly the United States with bringing mobile to social networks. And you could see in each of those cases, it had a huge impact on the society, on the innovative engine, and on the economic benefit for the country. And that's why we've been seeing a battle for 5G, because each region wants to be the lead of that. On the left is basically the idea of a smart city, where now we have the potential to connect everything. And the right is like petroleum, end-to-end capabilities. And probably even now, petroleum companies still only have disparate capabilities along the way. But again, the potential is to connect all across the board, end to end, where you have a dashboard that can see from beginning to end, and where you can troubleshoot all along the way and track things along the way. But this is why security is such a critical point, because now we're giving our crown jewels up to those who operate our networks. There's access into our critical infrastructure, our energy grids, our transportation, our factories, that never had this kind of remote mobile access like it does now. And that's why it's very important that we have service providers and vendors that are very trustworthy and proven out. There we go. To me, this is a very important slide as it relates to what the 5G is. So much of the attention continues to be focused on the core network. And although that's very important, meaning from the radio, the core, and all, it's these bubbles, these advanced technologies on top, that is where the innovation is going to take place. And I think a lot of the economic revenue, the margin takes place for the companies. That's where we see autonomous vehicles, drones, surveillance equipment, augmented reality, virtual reality. This is where we're going to see so much of the transformational opportunities that can run on the mobile network that provides that foundation. And I think this is a very impressive list of benefits that commercial 5G can bring to the Department of Defense. There's so many different attributes that we can take advantage of the large scale and reliability that a commercial mobile network does. It's based on established standards, internet protocol, as well as the standards body of 3GPP. Then we have widespread adoption. Up to last year, it was 1.6 billion subscribers already on 5G, and now over 300 mobile networks are using 5G. A cost benefit from scale includes handsets, hardware, software, all along the way. Very reliable. The service providers require 99.99% reliability. And so this is something, again, that we can tap into. Diverse data set, so you can go from very high definition video all down to little sensors and everything in between, mapping data, all different kind of capabilities. And 5G is actually being optimized at all those different levels. And then scalability, same thing. Can be just a couple of users in a private network, all the way to millions of devices connected. Enhanced security, 5G improved on security over 4G. And then even the commercial, NSA's commercial solutions for classified has been adopted for 5G. Spectrum diversity, low band, mid band, high band, and then diversity, agility even within that area. And then this one is really something, again, the connecting to satellites or non-terrestrial networks. We have, that's in the last year or two, that has grown so dramatically beyond anybody imagined. And again, for the warfighter, so important for connecting remotely. Whoop, back, I didn't finish here. Other things related to the warfighter in terms of an agile environment, we have edge computing, so you can keep the data closer to the end user where decisions can be made quickly. Private networks, which can be flight lines or ports, as you'll see in the next slide. And again, where you have a little more security and you can open it up to the outside if you want, or you can keep it more private. Sidelink was originally being designed for vehicle to vehicle, but it can also be troop to troop, person to person. And so as that develops, I think there's a lot of potential for that. We went again. Network slicing. The Norwegian Defense Ministry is already using this, using a public network and slicing off their portion of the network in order to have privacy within a public network. And the last two are basically, again, this is a technology that has a future. The bubbles that I talked about, the emerging technologies are going to ride on top of it, as well as a future where you have FutureG and 6G and so on. And again, this is just an example of a port where there's an endless application, the potential for ubiquitous connectivity, and we could have a same slide as it related to a flight line or other type of private networks. And then my last two slides, this is where we connect for DoD people, connecting with us, DIU, so that we can work together with you and sort out your issues, identify what funding you have, and then how we can bring this out to a solicitation, which gets us to the end user companies. These are critical websites for you. If you're interested, the key thing is to sign up. Anytime a solicitation comes out, you're going to be notified immediately, but then you only have usually 2 weeks to respond to it. But again, it's either a 5-page written write-up or up to 15-page PowerPoint, meant to be pretty simple, and then we try to make the choices pretty quickly through that. And let us move to the next speaker, and we're going to have Ian talk about Turbine 1. Go ahead, and I'll let you have this.
Oh, great. Let me put this down.
Okay, good. And if you're going to stand here, we'll put this back up.
Thank you. Let's do this. Whoa. All right. Whoop. Stand still. It's moving. All right. Hi there. My name's Ian. Thank you so much for this opportunity to chat. Again, I'm the CEO. This thing is driving me crazy. Hold on a second. Move. There we go. Okay. All right. So thank you for that wonderful introduction about the benefits of 5G. At Turbine 1, we are an intelligence application that sits on top of that wonderful infrastructure and network. So we're basically at the app layer. For us, it's an intelligence application. And I'm here, though, not to talk about Turbine 1 specifically, but the stories I have to share here for about 10 minutes, just to share a few stories here, is how great it is to work with DIU and OUSD R&E and NIWC-PAC. And I'm really here to represent their stories in partnership with what we've discovered in the field over the past year. And so it's an honor to be here. And I'll just share a few pieces here and again, encourage your feedback afterwards. So the scope of work that Turbine 1, see if this works? There it goes. The scope of work for Turbine 1 as a DIU partner was basically focused on this problem. It's, I think, an illustration that many of you recognize. How do you accelerate decision making when confronted with an overwhelming amount of data? Way too much data, not enough eyeballs, not enough hours in the day, not enough bodies to throw at the problem. What can you do? And so for us, the scope of work started with a relatively, I'll call it, simple problem of tracking aerospace ground equipment. So finding things. In the world of those of you familiar with targeting or ISR, this is the find fix of the find fix finish process. When we came out to Whidbey Naval Air Station, Whidbey Island, the Pacific Northwest, that was the challenge that they were facing and the origination of this question. Building on top of a 5G network, can we have an app come in to help people find what they're looking for? Basically digitizing a very paper-driven, analog, throwing dudes out in the field to try to track down tractors and stairwells. Why is this so damn hard? There's got to be a better way to do this. What's wonderful about working with DIU is the process and framework for experimentation and prototyping. So for us at T1, what started with, can I track aerospace ground equipment, evolved into force protection. It evolved into fire detection, counter UAS, and then industrial monitoring of gauges, like dials on a 1990s like power plant kind of a thing. So normally, that kind of evolution is the antithesis of government contracting. In this environment, we said, hey, what is the actual capability that we're experimenting with here? And it was a simple do-it-yourself toolkit. Can anyone find anything that they're looking for across all the hardware, all the sensors, all the data types, and give a toolkit to the end user, as pictured here, whether in a field tent environment or in the more traditional tactical operations center, battlefield environment? Can you give them a toolkit so that they can have all the sensors work for them? rather than the other way around. The key theme across all of those different use scenarios of fire and people jumping fences and even just traditional targeting, there's basically 3 common themes across all of these scenarios. One, the AI had to be simple enough for you to trust it. And as many of you know from the wonderful companies presenting here, AI and machine learning has a lot of mistakes in it. It's not perfect. It's broken constantly. So how do you have somebody who's not a data scientist, not a coder, how can they find ways to have these tools work for them? So that simplicity was a common theme across the board. Another one that we learned, and I'm grateful for folks like Johnson Wu and Kurt Andrews and other technical leaders on this project, we had to deal with a lot of antiquated hardware. We found some wonderful cameras from the late 1990s that had to be brought into a base defense operations center, a BDOC. And as a technical person, you know, we're AI people, we're tech people, we're going out there to change the world. Went out there, saw the data for the first time, and despite our assumptions, realized, wait a second, this is analog. This is a coaxial cable. I need to take an analog signal, make it digital, then convert it back to an analog signal just so we can show it on the TV screen in the BDOC. Didn't expect that necessarily, but when we got out there, realized if we're going to find cost savings and bring a no new hardware attitude to prototyping the field, we had to be flexible as a business and find ways to convert that information. And then from that, by the way, beyond even the technical side of all this 5G networks trying to bring antiquated systems to the modern era, we saw a general lack of what I'll call hardware interoperability. And again, it's easy for me as a software company to make fun of hardware. It's what we do. But the struggle was that a lot of these companies just either didn't have the commercial flexibility or even the technical capability to bring out, to liberate data from their silos and put it into an operational environment where folks could really work with it. So this was the problem we encountered, right? And again, we needed to have at T1, as much as we being NIWC-PAC and DIU, the flexibility to iterate and find out more of the actual needs once we actually got out there. So here was the solution for what Turbine 1 was able to at least bring to this problem. It's all about adaptability at speed, the speed of the mission. So if it's force protection, there's a certain cycle time for a guy jumping a fence. I'll give a very concrete example of something I was surprised for, again, maybe a little entertaining, if not terrifying, for what it's like to work in these kinds of environments. Very publicly, Naval Air Station Whidbey Island, does not have a full fence. I don't mean that metaphorically. I mean literally, you could stay at an Airbnb on the beach, walk up the beach, walk onto the airfield, and there's physically nothing to stop you. So we, as a Intel app, on top of that environment, said, wait a second, is there a gate? Is there a camera? Nope. Well, as a software company, we said, no problem. We will create a very interesting solar-powered sensor system, put it on a cement block, literally, and park it on the northwest corner of this airfield so that we can even bring 5G to a otherwise dark area, by the way, so that we can have this Intel app deployed in an environment to make sure that some idiots that were walking up the beach could be found, detected, identified, that the right information can get to the right person at the right time, in this case, the military police, to go prosecute these idiots that were walking up the airfield doing things that heaven knows what their intentions were when they're walking onto an active runway. Another example of adaptability at speed, I would advocate for those that are the businesses in the audience, you got to find ways to make things easier for the government. In our case, we were fortunate enough to have the contract with DIU expand away from Whidbey Air Station here to Hawaii to, it's a NICTAMS comm center. So basically, for those of you that are from here, Lu'u'u'alei. The government wanted to take, for those that are AI and machine learning experts, for those that have built detectors for one base, DIU said, hey, can I take that same software and take it over to this other location and then customize it for the local environment that is Lu'u'u'alei? As a software company, we said, absolutely, not a problem at all. Enterprise-wide license, the government owns this data, you built it, you own it, have fun with it. So we were able to take a capability built in one local environment, but enable another base to basically tune it for their local needs and do it without any additional cost to the government. Another example I would say just on that side, again, within the interoperability area, for those of on the government audience perhaps that are in acquisitions or buying, if you have not bought from a software company before, I mean just one point in that area, when you buy from an enterprise software company, when we found that there was not a lot of interoperability between systems, we provided it at no cost to the government. That may be different for those of you that are used to working with the software factories or the billable hour shops, which are wonderful for staff augmentation, but when you want capability fast, if you haven't bought from an enterprise software company before, really recommend it. It's really fun. It's great for you, and it can give you all sorts of commercial flexibility to bring more capabilities forward. And then maybe just to round off here, I'm going to go a little techie on the 5G side, and I'm going to go off mic for this one because I just love this slide this much. Okay, so the best part about 5G is also the worst part about 5G, and that is it's not always there. Weather, DDIL, jamming, tyranny of distance. On some level, the 5G is not going to be there for you. So in general, when it comes to AI, and maybe just as, well, I won't poll survey the audience, I should have done this sooner. Many of you that are AI and machine learning practitioners know that generally speaking, if you build something in the cloud, which is the lower left-hand portion of this illustration, and you try to build something in the cloud and then bring it to a mobile device, you usually have a hell of a time doing it, usually because of bandwidth. The typical machine learning model of gigabytes or petabytes, if you're putting it through a 100 kilobyte per second straw, good luck with that. It's going to take you a few days to be able to do that. Now, on the other side, what we learned at T1 is if we actually build for the edge, no cloud, no code, no problem. That's super weird. That is not the majority of the AI tools you all probably use today in some form or fashion. So if you build on the edge, you can scale to the cloud through 5G much more effectively. Going the other way usually doesn't work. So if you have a system that says they're edge, but they build in the cloud, that's not edge. That's a lie. That is you just got hooked onto something that you're never going to be able to take on the drone, on the submarine, on the USV, because it was built in an environment that is way too big and cannot be miniaturized. So I want to talk more about the tech side because I'm a geek for these things, but I'll cut myself off to basically say part of the technological inventions and experiments that we were proud to be able to learn from in the field with DIU was the two dimensions of how you actually do inference data. So, as many of you know, garbage in, garbage out when it comes to training. So how do you have local training by the operator, not T1? You, the warfighter, you, the petty officer, you, the sergeant, can build this stuff yourself. You don't need us. You should be able to take this toolkit wherever you are and have it be locally adaptable to your mission, your operating environment, your sensors, your drones, whatever it is. While at the same time having the ability to customize it for your local operating conditions. This is basically the tech scenario that we had to experiment with and are proud to have been able to advance with DIU. So I think I'm at my 10-minute mark-ish. So in closing, oh, I didn't even tell this one. I'm proud to say that I forgot I had this slide. Proud to say that folks that have used this are advocates for the technology and keeping it forward. Actually, I'll close on this one. So with DIU's structure, we are proud to be considered one of the DIU success stories. We have earned the highly coveted success memo from DIU, which for those of you that are contracting geeks know that it's a basically platform to accelerate the transition from a prototype into a production level contract, OTAs, things like that. We've earned one. And without giving specific details in this environment, I'm proud to say that it is being leveraged. I've gone all the way through the DIU experience, from that random solicitation that I learned about on LinkedIn, winning the opportunity to be able to partner, learning in the field, getting the success memo, and now Turbine 1 is transitioning into production, into an operational environment, the TRL 9, for those of you that know that language. We've achieved it. We did it. And we only could have done it with great partners like OUSD R&E, like NIWC-PAC, and of course through DIU's great commercial engagement. So that's it for me. If you want to learn more, please pepper us with questions. The Turbine 1 booth is like 100 yards that way. I have a very successful, very brilliant partner named Ed Padinsky right over here who can tell you all sorts of stories about what else we're doing out in the field. And so I really just encourage you to come on up and pressure test some of the stories that I've told you today. So that's it for me.
Great. Thank you so much, Ian. And let me pass it off to John. Great. Thank you from Cape.
Thanks, Dwayne. Okay, I need the clicker. I'm going to try it from over here. First, I'll say, if you don't spend a lot of time around founder CEOs like Ian, you may not appreciate how rare it is to see one of them keep to a time limit, so I'm really impressed by that. I'll do my best to also hit the 10-minute time hack. If I can figure out where to click. Can I get a little help? While we're working on the deck, reintroduce myself. I'm John Doyle, founder and CEO of Cape. It's a company I started 2.5 years ago. And we are focused on a problem. Basically, how do we take all the amazing potential in 5G and amazing potential and advantages of commercial cellular networks that Dwayne was talking about and Ian's talking about, and address some of the issues that come when you connect to commercial mobile, specifically issues around privacy and security that I would love to tell you more about. That's all right. You can imagine in your mind the slide that I had to start here to say this. CAPE is building a mobile virtual network operator, or an MVNO. What that means is we're a cell phone network that doesn't own any towers. We lease capacity on towers from major carriers all around the world who have lots of money and lots of spectrum and own towers. We lease capacity on those and then deploy our software, which is everything else you need to run a mobile network. So we manage authentication, call routing, messaging, connection to the internet, billing. All that we control, and our partners provide the towers. We use that footprint to build features that improve privacy, security, and resilience on commercial cellular communications above the industry baseline, which on my next slide that you may see eventually is full of headlines demonstrating that the industry baseline is pretty poor. So imagine, if you will, a slide full of headlines about recent data breaches, geolocation incidents, all the ways that US adversaries leverage commercial, and other malicious actors, leverage commercial cellular to compromise users of that technology, which is basically everyone. And certainly everyone in this room has a cell phone in their pocket full of their personal information, and therefore is subject to the sorts of problems that we're trying to solve here at CAPE. I think we're close. Hey, here we are. I'm going to start back from the beginning. Not really. Here's that first slide. Oh, it's an amazing team. I skipped the team slide. It's an amazing team. We have, in addition to great partners in the government, like NIWC-PAC and DIU, we have amazing investors. Andreessen Horowitz was our first investor and remains our largest investor. A bunch of great defense and consumer-focused investors, amazing advisors. Okay, here's the headline slide. Good. I won't dwell on it because I already talked about it, but we chose these headlines carefully because they demonstrate that the set of problems CAPE is attacking are domestic as well as international, and that they're widely varied, right? There's not one vulnerability in the 5G protocols that we're trying to solve, and once we do, that's like a silver bullet that makes us all okay. It's a literal PhD field of study to think about the vulnerabilities in the commercial cellular network. We diagnose it as a problem of transitive trust. So like I said, everyone in this room has at least one cell phone and maybe as many as 3 or 4 in their pockets. Those cell phones are full of your personal information and your professional information. Those cell phones are seeking to connect to whichever cell tower seems closest and strongest. And when they make that connection, they're surprisingly forthcoming in what they share. And then the networks all trust each other. This one's a little more subtle, not always as obvious. Turns out to be more profound. Global cell is not a big monolithic centrally managed thing. It's a patchwork of carriers around the world who have agreed on a set of standards by which they'll talk to each other to accomplish really important things like enabling you to roam seamlessly internationally, allowing you to connect calls between carriers all around the world, the ability to reconcile bills when you roam and you come back home. Really important set of functionality and all the stuff that Dwayne was talking about. But in order to accomplish that interoperability, the commercial carriers, I'm sorry for the feedback, assume an enormous amount of trust in each other. And they use the now famously outdated perimeter-based security model, which is once you convince GSMA that you're a carrier and you can get hooked into this global cell network, you're assumed trusted. And that creates all sorts of problems, especially when you consider that a not insignificant percentage of the telcos in the world are state-owned, including by US adversaries. Okay, architecture diagram that we're going to breeze through quickly, but just to give you a sense of where CAPE builds, remember we don't build the tower, we build the cloud infrastructure, so all the rest of the software, a mobile core, 5G non-standalone mobile core, OSS, BSS, IMS, all the things you need to operate a telco. Ours all runs in commercial cloud, so it's very scalable, deployable anywhere, agnostic to the physical infrastructure that we hook it up to. And then we have presence on our device. We're a bring your own device organization. Your iPhone works, your Android works. We deploy a carrier application via the app stores that lives on there. It has slightly heightened permissions. Namely, it can control the SIM card. We build our own eSIM profiles in little guys called applets. That's the platform. That's the footprint we use to build our features. And rather than tell you about them, I'm going to show you an example here in a minute. First, we'll talk about this exercise. This was a really great proof point for the company about a year ago. We went live in Kansas City on 100 towers owned by a major US carrier and supported a DoD partner as they conducted a very awesome 10-day simulated hostage rescue in Kansas City using unmodified Google Pixel devices for their phones for the entire thing. The red team, the bad guys, were US Marshals using all of their technical surveillance gear in the backs of trucks and on fixed-wing aircraft and helicopters all buzzing around Kansas City. And another DoD partner who specializes in these things had network-level access to the carrier just to simulate a hostile, either a compromised carrier or a carrier in a contested environment. Fast forward to the end of the 10 days, the point is they couldn't find us. Those two red team elements working together couldn't locate the phones of the hostage rescuers over 10 days. Was a pretty significant result, certainly for the company, but also for our DoD partners. And kind of was the initial validation of our design thinking and our decisions up to that point, which led us to, before we get to, we're going to talk about NIWC-PAC and DIU, but first a brief demo video. That kind of set of features that we deployed in Kansas City, we recently tested in Ukraine in advance of deployment, actually with a commercial partner who's sending a lot of engineers into Ukraine right now and wanted additional protection for their people. And so I just wanted to show you a brief, it's less than 3 minutes video, highlighting some of our features. This is how we enable our subscribers to take control of their digital identity as they move around the commercial cellular network, right? So not private 5G, where it's relatively easy to lock things down, but the kind of Wild West, sometimes literally Wild West, of commercial cell, in this case in Ukraine.
Hey everyone, Nick here from Cape. I've just returned from a trip to Ukraine where we were testing new roaming network partners and device capabilities in the wild. The following day from the hotel, I prepared a number of devices for testing. With Cape services, I'm able to programmatically retrieve various device identifiers from our backend servers. So from here, you can see I'm retrieving IMSIs, in this case full eSIM profiles, from various roaming partners that we have. Here I'm retrieving some from Plus and Play out of Poland, as well as O2 out of the United Kingdom. In addition, I retrieved IMEI values. I'm using low-end Android devices from the IMEIs that we made available. Next, I'm using a concept that we call persona, effectively an IMSI and IMEI pairing together. We've also included a new feature, advertising ID rotation. This allows our customers to counter both close technical surveillance and network level surveillance, and application layer ad tech correlation as well. Here you can see I'm creating various ones such as bed down location and meetup. Next, we trigger these using geofences, either circles or polygons. Our first stop from the hotel is the Presidential Palace. At the palace, we used our device's first persona, which was our meetup. Once we hit the perimeter of the palace, I was met with barbed wire, barricades, and some armed patrols. Here we are, smack dab at the edge of the palace. As you can see in this menu, at the meetup location, we're using a Polish Plus IMSI, and it peers to the network as a Samsung Galaxy S4. We're using one of their roaming partners while we're in country. Finally, our last stop was at the Ukrainian Motherland Monument. We ended our testing on a beautiful day with the Ukrainian flag blowing in the wind, and we entered this geofence using our development persona. Here in our dashboard, you can see the IMSI ended in 9783 and our IMEI ended in 3956. Going into our hidden menu, we can actually go on the device side and verify that the changes occurred as expected. So here we are, using this IMSI as well as this IMEI as expected, and roaming onto UA Kyivstar as our roaming partner from this particular Polish SIM. So this concludes our test in Ukraine, and throughout this extremely lengthy multi-country and multi-mode transit journey, we iterated rapidly to refine our application, ensure continuous network connectivity, testing roaming partners, and this has already resulted in CAPE devices being fielded throughout Ukraine via a partner organization. Thanks for watching, and stay tuned for further developments from the CAPE team.
Cool. So if you don't care about things like IMSIs and IMEIs specifically, your takeaway here is Nick was able to go to Ukraine, continue to leverage existing commercial cellular infrastructure during his entire trip, but mitigate a whole host of threats represented by the headlines on that previous slide. What this means then in terms of our growth with the government and growth with DoD partners is the same platform we built that enables us to be successful in Kansas City or to send Nick to Ukraine. It also turns out to be really valuable as an iterative platform and as a place to start our relationship with NIWC-PAC and with DIU. We're fortunate to be partnering with the Navy on deploying our network to Guam. So on Guam, we're integrating right now 2 of the 3 major carriers, deploying those same privacy-enhancing features as well as some cybersecurity enhancements and executing against other requirements as well. It's been amazing. All the things that Ian says about the wonderful fluid nature of this sort of partnership, I would echo. Including while our team was on Guam, we had the opportunity to be invited aboard the USS Abraham Lincoln. I say me, it's actually Drosten, who's in the back row, and a couple of our engineers were invited on board to test what does it mean to hook up an aircraft carrier to an MVNO like this when it's in a forward deployed location like Guam. And they had incredible success, and they showed really strong connectivity speeds from surprisingly far out. It led to further testing and further iteration as the Abe steamed on towards the Philippines. They were able to continue to have really strong, in some cases surprisingly strong connections, and even establish connection from up to 100 miles offshore, which is a significant finding and is something that we'll continue to iterate on and research as the relationship evolves. Okay, and benefits to the warfighter. Dwayne really covered this. There's an enormous amount of potential to be unlocked in 5G generally, and our opinion is in particular, if you can leverage the trillions of dollars that we've spent worldwide on physical infrastructure to enable the commercial cellular network. Private 5G is a really important technology that certainly has a place, but it's never going to be everywhere. We've got trillions of dollars to go to catch up if we want to make that the case. And so where we're investing and where we're investing with our government partners is in making that pre-existing physical infrastructure investment usable for this kind of 5G potential worldwide. I did it, and I'm really happy to answer questions or to talk to anyone after this if you've got threads you want to pull. Thanks a lot.
Great. Thank you, John, and thank you, Ian. Our treasured partners here to work together with, and so really very thankful that you guys were able to come and share these things. It's good. Before I open it up to everybody for questions and answers, I just want to ask, I'm going to provide a question each for Kurt and Chris to make sure that they don't feel left out here. So Chris, many of you know, has been very active in 5G. I'm sorry, Kurt, let me start with Kurt. Kurt, for 5G on the Indo-Pacific region here. And so, Kurt, can you share us a little bit more about what DoD is doing as it relates to 5G here in this region?
Yeah, sure. Is my ISAM on? Okay. Yeah, let me go back a few years to 2020 when we started the 5G program here. And the idea out here was to fix aircraft. There was a number of projects funded by OUSD 5G program. The particular one that landed in Hawaii was focused on aircraft maintenance and readiness. And believe it or not, Turbine One was involved in this at the time, along with other people in this room. And so we had a number of use cases that came out of it. So not everything in the 5G world has actually come to fruition. I think we all know that, right? So the one I'm going to talk about first is, this machine-to-machine, automation on the flight line, which, yeah, I keep pointing at them. So they had a FOD dog that we were running around Hickam Air Force Base with. And the idea is it would replace the airmen that walk on the airfield every day looking for foreign object debris. And they had a nice little robot that did that, four-wheeled robot. And it wasn't that the technology didn't work, and it wasn't that the 5G wouldn't support it, but just as I think you're seeing with, the driverless Ubers and things like that, yeah, not everything comes around as quickly as you might think. And in this case, it was clearly the policy of allowing an unmanned robot to roam around the airfield with jets, and you could never overcome all the safety issues that were associated with that. The ones that actually do work, though, are generally associated with machine learning and AI and aircraft inspections. So, for example, right now we have quadcopters or small UAS flying over C-17s and P-8s so that they're inspecting them, basically, so that an airman or a sailor doesn't have to walk on top of the aircraft to do those types of inspections. So we have similar ones, similar types of inspections that are going on. So from a use case perspective, in the aircraft maintenance world, that's kind of one set of things going on. From a networking perspective, I think what we found is it's all about connectivity and maybe bandwidth. And the DoD bandwidth is always great. Nobody ever turns down bandwidth, right? And says, I want less or something like that. That rarely happens. But the connectivity is clearly important. So we were often looking at places that had no connectivity already, such as parts of the hangars and especially at Whidbey Island, where we are doing some work. Established our own, quote, private networks with partners like EchoStar and Hughes, Verizon here on this island. But what we also realized is that affordability is important. And the public networks, when they're operating at 99.999 uptime, it's just hard to compete with that. So as a general theme, if the Department of Defense doesn't have to own it, maintain it, we're happy to pay somebody else to run it. It's just kind of a general statement. But there's obviously going to be places as we look, especially west, islands, we call them places, not bases, that there maybe won't be networks. And so we want to be prepared for that. And in that space, I think we're looking at, the ability to project forward, to bring 5G into that world, into that space. What would be great is if those networks that we project forward also work, the SIM cards, the technology, also works on the other networks that are in those areas, the public networks, right? So it's very seamless. So you have you can deploy warfighters, give them SIM cards, give them phones, no matter where they're operating in a DoD kind of world. I mean, when I say that, just like we're operating in here with our government phones, some of us, right? It's all seamless. That I think is our vision. So I think I'll stop there. Okay. Yeah.
Great. Thank you very much,
Yeah.
Kurt. And then, Chris, can you just share a little bit more where you see 5G going in the future, and what are kind of the operational needs?
Yeah, there's really two areas I'll focus on with regards to operationalizing 5G in the DoD and in the Indo-Pacific and some of the mission sets that we're specifically focused on. The first one is with sustainment. In the sustainment realm, you could imagine some hundreds or thousands of unmanned systems which need to be ready to be deployed within a fairly constrained timeline. But that deployment may be 1 year out or 3 years out, we don't know. So you're in this strange zone of, I need to be ready, but I also need to be in layup, which presents lots of mechanical challenges, but also lots of digital challenges as well. So if I've got them stacked in a warehouse, for example, how do I maintain a system status check on a fairly regular routine basis? How do I support over-the-air updates to ensure that the parallel continually developed software and improved software stacks, improved autonomies are routinely deployed to these systems? It gets to the ability to leverage in-place infrastructure without having to deploy which takes time and resources, maybe wired or more bespoke systems. That also gives you a lot of flexibility to move wherever these things are stored, from a desert to a coastal city to a place forward to maybe some place that isn't necessarily well advertised or represented, right? You can take advantage of a lot of that local infrastructure to support that sustainment piece of it. Also, with regards to logistics and contested logistics, being able to track our stuff and our things and be able to feed that back up into more unified joint sustainment decision tools that we can then use to make more informed decisions about prioritizing either the timeliness or resiliency of our logistics networks. It feeds into that. So 5G, and specifically leveraging commercial and public infrastructure to support that, is huge. The other side is supporting actual real-world operations. And with that, we'll focus on unmanned systems. And 5G is not the primary method by which we will control these things. They are part of our PACE plan, the resiliency that we're trying to build, with the recognition that we can disrupt networks temporally and spatially, but few, if anybody, can ever disrupt everything everywhere all the time in all the geometries that you would expect to come against. And so when I pair 5G in a littoral environment to control sea lines of communication or area denial in littoral environments, then I have that 5G option backed by my mesh networks, backed by my high frequency networks, backed by my space enabled networks and my beyond line of sight communications. And in the future, I would love to see two things from 5G in particular. One is improved and increased 5G from space. That now takes that technology and brings that into the beyond line of sight realm, and our efforts to bridge disconnected space infrastructures with each other. That has active work going on within DIU right now. So cross-banding between different satellite networks on orbit. And the other one is 5G sidelink. If we can field and prove out a chipset that supports that, that's hugely important, especially in those higher frequency bands where I can mitigate any dependency I have on $1 million 5G base station, which in the realm of all domain attributable autonomous isn't a reality, right? I'm not going to take a multi-$100,000 thing and put $1 million antenna on it, and then how many do I put out with a group of 20? 1, 2, 5, 10? If I put 2 out there with a group of 20, Murphy's Law dictates that the first one to not work out of the deployment will be one of those 2, and the other one will be the second one to get blown up, right? So 5G Sidelink helps me distribute that risk and that investment across those. So in the operational space, 5G integrated into our network control planes will be a huge enabler, from 1 mile out to 30 miles out to potentially up to 100 miles. And I like both the lower and higher band frequency spectrums for 5G for various different reasons. So give me both. Open for questions as well.
All right, great input from all of you. Thank you so much. All right, let me open up to questions here. Raise your hand and I'll bring the mic. You had your question earlier. Go ahead.
Yeah, it was on your solicitations. Is it open to anybody? Do you do it to Fed Biz Ops, or how do you do the solicitation?
Okay, Johnson, you want to answer that?
Sure, I'm supposed to be just a heckler. So I'm Johnson Wu. I run commercial engagements for the cyber and telecom portfolio here at DIU. All solicitations are not posted on FedBizOps. They're on www.diu.mil. I strongly encourage our commercial partners to get on the website and sign up for the newsletter so that you can be notified of all the opportunities.
Great. Okay, go ahead, Chris.
Is the mic on? Hello?
Here we go.
Quick follow-up. I recently took a question from a commercial engagement I had, and they said, we were told that we weren't the right company for DIU. I said, who told you that?
And it turns out it wasn't a DIU person, but that's a fallacy, right? If you are any business interested and have a product that meets our commercial services offering or solutions offering criteria, like you can apply. Several of our recent CSOs, we've had big primes actually apply and be awarded prototype contracts in partnership with other non-traditionals as part of that. So whether you fit in the primes or you're scrappy and small, you fit our model.
Nice. Thank you, Chris. Yes. Go ahead, Chris.
Hey, Chris Ward from UDA. Follow on to that question. Is it U.S. companies only, or can coalition industries also apply?
So yes, international companies can participate. There is vetting that goes on all the companies, so it needs to be one that is trustworthy, but otherwise, yes, for sure. And also, again, DIU has been embedding people within these countries specifically to try to tap into the innovation engine in the other countries. So it's being encouraged as well. Yes, sir?
Just caveat that.
Okay.
Just a caveat, though, watch the solicitation because many of our IC cybercom partners, they'll write on there if it's open to foreign entities as well. So the solicitation will let you know exactly who can respond.
Good. All right.
Rajiv Gopal Hughes. A question for Chris. PACE plan, the whole concept has been around for a long time. The way threats have increased and how fast they are. So there is a talk about dynamic PACE. So is that the focus area as well for DIU? So that PACE itself can be automated and things can be selected very quickly based on the threats as they are changing? Because when you combine satellites, 5G, all sorts of line of sight, beyond line of sight, we are literally taking two different worlds and bringing them together. And it is possible today, but it's a big landscape.
Yes, we are really exploring different types of network control planes, software-defined wide area network-like technologies. What's unique about maybe doing this from fixed infrastructure perspective, which if you look at how the internet runs, that's essentially how the internet runs, right? But when you take things that bob, float, and move in three-dimensional space in the real world with constrained compute or inferencing capability, then we're starting to look in new applications for that old technology stack. And that's where we really see, that DoD commercial, alignment where I can't just go buy it on GSA, but it's also not really available from your traditionals.
Great, thank you. Any other questions?
Also, we are working with a chip maker in Japan right now to buy chips that are focused on, providing more efficient compute and edge inferencing at the, sub $1,000 price level.
All right. Well, as a last question, let me, if everybody can make a comment to the companies who are out here who are interested in trying to work with DoD in the Indo-Pacific region, what advice, brief advice might you have? Okay. Go ahead, Chris.
All right, we'll start here. Well, exactly what Johnson said. www.diu.mil. You don't have to check it every day. You can sign up for email alerts. So I would apply there first. If you think that you maybe aren't relevant, the bar for putting in a proposal is fairly low. Put it in. We read every single one, and DIU's nature has shifted and changed a little bit in the past year since we got a budget. So we partner really heavily across various labs and other entities, and we are highly focused on delivery capabilities to meet combatant commander requirements. And so we don't work alone. If you have other partners and you think that you have something that may be applicable here, reach out to our local embeds, and we want to help build that network. The last plug I'll put in is we have a growing network of on-ramp hubs which are, we have one here in Honolulu that is growing, and that is the front door to DIU for folks that maybe don't have big space access or are trying to figure out how to do business with the DoD better.
Nice, thank you.
Yeah, my only, I guess, add on it. So I'm a customer of DIU. I work for NIWC-PAC. But what I will say is, and it's interesting because I'm looking here, again, familiar faces. You have the FAR-based acquisition world, you have the other transactional authorities, and then DIU is kind of even a one step further, to the good side of that spectrum, right? So especially if you are a small company, non-traditional, as a government, like Ian, he originally applied to keep track of aircraft ground equipment, and now because the customer, right, wanted, we had a commander that had a big security problem. Yeah, they were flexible enough to allow him to work on things that really needed to get worked on, and very quickly, much faster than any other transaction authority I've worked with. So.
All right. That was going to be my advice also, actually building off what Kurt said, which is to recognize that DIU values in companies the same thing that companies value in DIU, which is the ability to move fast and actually deliver. And so just like we love DIU because they can show up and they can get things done quickly and help us deliver solutions to our partners quickly, they also value companies who show up and move fast and are flexible and responsive to needs and can grow together with the requirements. And so if that's you or if that's your company, then it's probably a good match.
I guess 2 final unconventional recommendations. If you're with the government, just give your money to DIU, trust in that. And if you're in industry, Turbine One is hiring, so come talk to me afterwards.
Hey, fantastic. Let's thank you all for coming, but also let's thank the panelists here. Thank you.